Welcome, everyone. My name is Kim Davis. I am filling in today for Zach Semke, and I just wanted to welcome you and introduce our hosts. Today we have Shannon Pendleton, Sean St. Amour, Kevin Brennan, and a special new co-host. I will hand it off to Shannon, who will fill you all in.
Amazing. Thank you, Kim. And welcome back, everyone. Welcome, Accelerator friends. I hope you've had a spectacular and restful summer because it's time to get busy. I'm Shannon. I lead Passive House projects at Sanderson Sustainable Design and Source 2050's High Performance Marketplace. I am very excited to be back hosting today's Construction Tech with my Passive House brothers, Sean and Kevin, and announce that Ilka Cassidy from Holzraum and the Passive House podcast will be co-hosting with us every third Wednesday. So welcome her in the chat, turn on your camera, rename yourself with your location, and prepare for today's presenter, Ed May, who's going to share his extended universe of energy modeling hacks and help you increase the value in your energy modeling workflows. Ilka, it is amazing to have you here. Thanks for joining us.
Yeah, thanks, Shannon. I'm super excited to be joining the team here. And Kim asked me to say a couple of words about myself. So I'm an architect. I'm a Passive House consultant. I have been the co-host of the Passive House Accelerator podcast for the last couple of years. And I am a big fan of Ed May and energy modeling. So I'm really excited that this is actually my first hosting today. So I'm excited about hearing more about energy modeling from Ed May. And I am giving it over to Kevin.
Well, thanks, Ilka. I had the great pleasure of attending the International Passive House Conference with Ilka and Mike and Zach. And she's a great addition to the team. The technical information that she has at the tips of her fingers, both culturally and for details and Passive House, is phenomenal. So I'm excited to have her on the team of Construction Tech. I brought it back old school with the old background here where we started. And one of the main drivers of why we started Construction Tech was because of people like Ed and all that they have to share. So he's going to bring the technology, the technique, and the technical for sure. So rather than holding up and hear my self-talk, let's get the show on the road.
All right, let's do it. So the venue I have today might have some fun background noise, so hopefully you can still hear me as the venue is quite fun. And of course, we say fun with a PH. And here we are. As Kevin said, we're here for the technique, and the technology, and no other than Mr. Ed May to bring his wisdom of wizardry to us today. So here we are. Ed is a licensed architect and a lead green associate. You received a Bachelor of Fine Arts from the University of Massachusetts at Amherst in 2001, and a Master's of Architecture from Parsons and New School in New York City in 2009. Ed has been an adjunct professor at Parsons, the New School University, as well as industry professor at Stevens Institute of Technology in New Jersey, where he directed the 2015 Solar Decathlon program. In addition, Ed teaches the Passive House Academy, the North American Passive House Network, and Passive House Canada, and is certified by the Passive House Institute in Germany and the Passive House Institute in the US, SPIAS, as a certified Passive House consultant. And he is one of the leaders in Passive House, and we're so delighted. And there's very few people that have been presenting on the Passive House Accelerator Live. And I think if I was able to give him a jacket, he would kind of get the 5-time presenter award for taking the lead as being one of our instructors and hosts on Construction Tech and being on the live. So Ed, take it over. I know you're familiar with this role. We're a pleasure to have you, and the floor is yours.
Wow, quite an introduction. Thanks, Sean. It is really fun to be back for, what did you say? This is the fifth time now? Fifth. Wow, that's crazy. How time flies. In any event, it is super awesome to be here with you guys, and big hello to everybody here in the audience who I know, and a lot of new faces as well. So glad that you're here with us, and I'm really glad to be part of this new season of Construction Tech Live. So yeah, let's get right into it. I'm going to share my screen, and hopefully this works okay. I am coming to you guys from sunny Antwerp, Belgium today, so hopefully the internet holds up and you're able to see and hear everything well here as we get into it. If anything goes wrong, give me a shout out. Hopefully we can do something about that. Okay, so I am here today to talk to you guys about passive house modeling. Now, that might sound a little weird for the construction tech group here. You might think, well, we don't do models. What I'd like to talk a little bit about today, though, is for those of us who are maybe not on the modeling side, but maybe more on the ownership side or on the design side. How do we understand what our passive house modelers are doing? And then from a project management and an ownership perspective, how do we maximize the value of these passive house models that we're building during the design phase of our projects? So that's what we're going to kind of talk about here today. I have a lot of thoughts on that. And then obviously I'll be really interested to hear your perspectives and thoughts as well as we get into the discussion portion later on. So let's get right into it. So my opinion. So as Sean said, I have a lot of experience doing passive house. We've been doing it for more than 15 years now. And we, in addition to all my teaching work, we do professional passive house consulting for all sorts of different projects, small, medium, large, retrofit, new construction, multifamily, single family, what have you. But across the board, and this is just my opinion, across the board, what we see is that while the passive house framework and passive house models are incredibly valuable to teams, they help teams make a lot of important decisions. Right now, I think that too many of us are putting in way too much work into these models and are getting too little useful output from those models. So I think we're working too hard and not getting enough for it. And I think as an industry, as a group of professionals, we need to look at this challenge, and we need to figure out how to do better. We need to do a better job as passive house modelers and professionals if we want to expand the passive house framework to a meaningful scale within places like the United States. Again, I do see a lot of value in the passive house modeling, but I think it has a lot of challenges that we need to, as an industry, overcome. So let's just talk for a second. Let's just back up a minute and say, what are we talking about when we talk about passive house models? What the heck is a passive house model? When we use the word model, it's in some ways, it's maybe a little fancier than it needs to be. A passive house model is really just a recording of all the parts of your building. You can almost think of it more like accounting than anything else. A passive house modeler is at heart really just counting up all the bits and pieces of your building and entering them in to some pre-made calculator. And that's really all we're doing when we're talking about passive house modeling. So we're making a digital version of the building. We're gonna take some real part of the building, a window, a door, a wall, a roof, whatever, and we're going to turn it into a set of numbers. And the reason we do that is so that we can figure out something useful about that thing. So maybe we want to calculate energy performance. Maybe we want to look at thermal comfort. Maybe we want to look at condensation risk. Whatever it is, we're going to use that abstraction to determine something useful, something helpful about the building. And we do that so that we can make decisions. Right? That's why we model these things. That's why we do this, undertake this effort. So when it comes to passive house modeling, we're talking about a few very specific types of models. In particular, during this talk here, I'm going to be referring to what are known within the industry as the PHPP and WFI, or WFI passive. These are the two primary energy modeling or certification modeling platforms that are used in passive house world. PHPP stands for the Passive House Planning Package, and WFI is just another piece of software PHPP is used by the international certification, and WFI is used by the US certification. So they're basically the same. They have some small differences, but for the most part, they're going to take in the same set of inputs, the same type of inputs, and they're going to yield the same type of outputs. So they're doing the same job functionally. So what kind of things are we recording in these models? Remember, when I use the word model, it's really just a recording. It's really just a counting of all the bits and pieces. Well, for sure, we're going to take in all the site information and the climate and the orientation and the shading, all your building's geometry, of course, the size of everything, all the windows and doors, all those products and all their performance attributes, all the different assemblies and the constructions and the materials, the thermal bridges of your building. And then, of course, this becomes especially true in non-residential or multifamily residential, things like usage schedules. So like, when are people in the building? When are people not in the building? How many people are in the building? These types of values, things like hot water usage, as well as all of its equipment and piping, heating and cooling equipment and ducting and different elements. And then, of course, fresh air ventilation systems, all of its ducting, all of its different bits and pieces. There's nothing really magic here, right? Again, it's really just about taking these real life things, a duct, a window, a door, and turning it into a set of numbers that we can input into these performance calculators, PHPP and WFI passive in this particular case. Well, why are we doing that? So I said earlier, the reason that we model is so that we can determine something useful. So we can answer a question. We don't just model because it's fun to make a digital version of our buildings. We model so that we can figure things out, so that we can determine something about our proposed design. So we come into our models with a question. What is the X? Because we might model for all sorts of different things. We might say, what is the peak load of my building? And I might want to know that so I can buy the right boiler, so I don't undersize the boiler. I might want to know, what is the thermal comfort, the predicted thermal comfort of this very glassy room on the corner of my building. That might be an important thing that we would want to learn. We might want to model our buildings for the health outcomes, the likely health outcomes of the occupants. We might alternatively be interested, when it comes to the energy side, in things like, how much money am I going to spend on energy over the course of a year? Or we might, as we do in Passive House world, be mostly focused on the quantity of energy that we're going to use over the course of a year. We might model the kilowatt hours, or if you're in the US, the kBTU per year, the predicted energy consumption of the building. Of course, there might be all sorts of other things we might be interested in. One of the most common ones that we hear from folks now is not so much around energy consumption per se, but moving towards a metric that measures carbon emissions or carbon emissions equivalents, so tons of CO2 equivalent or kilograms of CO2 equivalent, something like that. And so there's all sorts of different things that we might be asking our model to tell us about. And again, the reason we want to know these things is so that we can make good decisions as designers and builders. Okay, so there's all sorts of different things that models can tell us. So specifically, what are our Passive House models telling us about? Well, our Passive House models are generally used to assess certifiability or certification. And when it comes to Passive House certification, we're going to be looking at primarily three different things. We're going to be looking at the heating and cooling energy demand. We're going to be looking at the site energy consumption. We might look at that as a total site energy or on a site energy per person. And then lastly, we would be looking at the source or the primary energy. Three different ways of looking at the energy consumption of your building, the performance of your building. We would use these at different phases during construction or during design to assess different sort of bits of the building and look at how the building is performing. But these three outputs are the three really key metrics that we're looking at when it comes to certifiability, and that we're going to be looking at in our Passive House models. So we're going to input a whole bunch of stuff about the building. We're just going to record all the things about the building. And then the model or the calculator is going to determine these values and tell them to us. And then based on those results, we can then go make decisions. We can increase or decrease the insulation. We can change the windows. We can rotate the building. We can take some design action based on these outcomes. Right? That's the general idea about how these models function. All right. Well, okay. So we're going to make these passive house models. So who exactly is it that's creating these passive house models? Well, there's no rule necessarily about who executes or creates the passive house models. They could be made or executed, created by lots of different people as part of the design team. Maybe the most straightforward and agent to execute or create the model is the designer, the building designer themselves. The building designer is going to be the person who has the most knowledge about the project status and the different particulars of the building. They would be able to iterate very quickly through lots of different options when it comes to the model and integrate the feedback from the model very directly into their design process. Now, on the downside, the design team already have a lot of other responsibilities when it comes to project execution. On the other hand, they might not have very deep or very nuanced knowledge about passive house protocols and rules in particular. The passive house protocols and standards have become much more complicated over the last 10 years than they were, let's say 25, 30 years ago. There's a lot of nuance to the various different rules and requirements, and it's very challenging for somebody who doesn't do it all day, every day, to be knowledgeable and sensitive to all of those nuances. So there's sort of pluses and minuses to having the designer themselves do the work. Well, okay, so what about another sort of team member? Perhaps, and we see this on many projects, perhaps the mechanical engineer would be the one to execute these passive house models. The mechanical engineer is going to have a lot of, assuming there is a mechanical engineer on the team, is going to have a lot of knowledge about the building systems. They'll be able to iterate relatively quickly, especially when it comes to building systems. And they're already familiar with a lot of the vocabulary, a lot of the terminology, and a lot of the processes of creating building models. And mechanical engineers already have a lot of that knowledge and experience from other domains that they can apply to the passive house domain in particular. Like the design team, though, the mechanical engineers are probably already going to have a lot of other responsibilities on projects. And so their time is already, in many ways, spoken for. They are also outside of the design. They're outside of the architectural design team in many cases, which means they're going to be reliant on the design team to sort of deliver to them, floor plans and envelope information and what have you. And on that regard, it is often the case that while mechanical engineers are very, very knowledgeable about building systems, they may not have the same breadth or depth of experience when it comes to envelope systems, materials, construction systems, and what have you. It's just not their domain that they typically practice in. Not all, of course, but many. So, okay, well, what about like an outside third-party passive house consultant? Right, they're going to have the most knowledge about passive house certifications, protocols, and all the nuances. They'll have a lot of experience around building envelope and a good knowledge of building systems, mechanical systems. On the downside, though, they are in many cases, if they're really outside consultants, going to know the least about the project. They're going to be entirely beholden to the design team to deliver all of the information they need to know to execute these models. So they are standing, in many cases, fully outside that design team. And that's going to be very common, especially when we get into much larger projects where you have many, many consultants, and you're going to be one of many consultants operating on the project. So communication and information pipelines become very, very important when you get or start to engage with outside consultants to do the passive house modeling. So there's no answer, but there are pluses and minuses to all of these. And at different scales, different types of projects, different types of teams, you might decide one or the other is the appropriate solution for your project. One caveat here, or one maybe just warning, if you're going to go down the outside consultant route and you're going to hire a dedicated CPHC to execute your passive house models so that your design team can focus on architecture and design phase, just remember the cardinal rule. This applies to all consultants, not just passive house consultants, but consultants work for you, not instead of you. You are not carving out a piece of the project and handing it over and then not checking in on it, not integrating the consultant into the design process, ignoring it, and just expecting that at the end of the day, they'll sort of deliver a set of drawings and you can just fold them into your sort of drawing set and call it a day without thinking about it, right? That's not how this works. The consultants are part of the team and they need to be integrated by the project management, by the design team, and they need to be actively incorporated into the process if you are an outside consultant. But again, there's nothing particular about Passive House there. That's just sort of consultant 101 when it comes to project management. Well, okay, so we've got a couple different folks that might be making these models. When, though, might these models be executed during the design phase? Well, typically what we see is, and this is especially with larger projects I'm talking about, but the same sort of pattern holds for smaller projects as well. We're typically seeing these Passive House models move forward in at least 4 phases, roughly contiguous with the typical design phases. Now, not every project goes through these design phases. There are lots of different project delivery sort of timelines that we see, but many projects are moving through the sort of typical schematic design development and then construction drawing phase into construction there. And so what we see is typically that the Passive House models are started or undertaken during the second half of each of these phases, and they sort of lead one into the next. And that's probably the most typical. Again, it's not a rule per se, but that's probably the most likely scenario that you'll see in practice. The other thing to say there is just that the models are going to incorporate different elements at different times. So during schematic design, before a lot of the building has been defined, we're going to focus most of the Passive House modeling on window to wall ratio and shading and overall massing and form factor, certification feasibility, and what have you. We're not going to get lost in the intricacies of every single thermal bridge during schematic design phase. We'll talk later on about how we integrate some safety factors and contingencies during these early phases. But we need to move quickly and assess schematic level outputs during the schematic phase. And then during the design development phase, we might move into things like systems in individual products. And then obviously during construction drawings or detailing is when we get into things like thermal bridging and airtightness integration details and what have you. So different elements are assessed during different phases of the project there. One of the challenges when it comes to building these Passive House models is to be able to execute early phase Passive House models before all of the project specifications and details have been defined. It can often be very, very challenging. We'll talk about that in a little bit. So, okay, so the conceit of this presentation here was around how to maximize the value of these models. So if you're doing a Passive House project, especially if you're doing a certified Passive House project, you're going to be creating one of these models. You're going to be making a PHPP or a WFI passive model. You're going to have to do that for certification. But as I said, what we're seeing is that a lot of folks are spending a lot of time building these models. They're incredibly laborious and very difficult to create, but we're not getting enough out of them. We're not getting enough value from those models. And I'm going to define value in this case as the useful output over the effort input. And I'm going to define useful in this scenario as information or output that has a meaningful impact on the design of the building and hence on the performance of the final building. So we want to increase the usefulness while decreasing the effort, and that will increase the overall model value. So we'll talk a little bit about how I think we can do that. How can we increase usefulness? How can we reduce effort? How can we therefore increase the value of these models? But first of all, who cares? Why does it matter? Why do we need to increase the value of these models? Why isn't it's sort of good enough? Well, from the design side, we need to improve our building's performance as a sector much more quickly, much more rapidly. We are currently far behind when it comes to achieving our climate goals in the building sector. We need to move much more rapidly, much more rapidly. And we need actionable, accurate, useful information about our designs in order to be able to move quickly like that at scale. Right? So from the design side, we need a lot more useful information, and we need it a lot faster so that we can move as a sector much, much faster. From the ownership of side, of course, it should be relatively straightforward. If you're the one paying the bills, I don't have to tell you that buildings are much more expensive now than they were 10, 15, 20 years ago. Buildings and building projects only ever get more expensive. And so it's important to try and maximize the benefit from every single dollar that's spent. We have an enormous affordability crisis in this country. And part of the way that we're going to work to combat this is to be more effective, more efficient in our work. Now, that's not the only thing that's going to help solve that problem, but that is one important piece of the puzzle. And then this is maybe this is an opinion that I hold, but I'm open to being challenged on it. As a professional modeler, I believe that we need to move to a delivery and fee mechanism where we are paid based on the useful input that we provide, not on the hours that we work. I think one of the important things we need to do as an industry is move away from getting paid for the hours that we labor to one where we're paid for the value that we create. And I think that's an important sector or industry-wide change that needs to happen. And so I think increasing the model value in that scenario increases the profitability of those different firms, the different agents that are working there. So everybody, I think, in that universe has a reason for wanting to increase model value. Now, one thing I believe is also that model value is not a static value. It's not a single number. I actually think that the model value sort of changes over time throughout the project. So rather than talking about model value as a single thing, we could sort of talk about model value at any point in time along the sweep of the project. So during the early stages, during the late stages, during the design phase, during the certification phase, what have you. What we see in practice and what we see in our own projects very commonly is that the model usefulness, again, I'm defining usefulness here as like yielding information that helps make the project better. It's not a very sophisticated definition, but like how useful is the model in making better buildings? That really peaks in the early stages of a project. So the usefulness, the utility of the model or the impact of the model is greatest at the early stages and then peters off to almost nothing towards the end. And that's really just a function of how many decisions are made, not the model per se, but right during the construction phase, most everything is decided. You have very few things left to change or revise. And so no matter what the model says, it's not going to be able to drive too much. Of course, it's still important and does still yield useful results, but there's just so few things to impact at the later stages that it becomes difficult. So the usefulness of the model sort of peaks early and then falls off. At the same time, so we can kind of plot the usefulness over time. Now, I think we can also plot the effort over time. So sort of, again, going from early stage on the left to late stage on the right, the effort, the amount of hours that go into the model start off relatively modest. They kind of plateau in the middle, and then they really ramp up at the end. What we see time and time again, and this is not particular to energy modeling, this is the sort of last mile problem that we see in 1,000,001 sectors around the world, is that last 10% takes forever. It just goes on and on and on and never ends. And there's always more hours to throw at it. That last 10% just is interminable. And at the same time that we're putting in more and more hours during that last phase of the project, we're yielding less and less useful impact on the building. And so one of the real challenges that we perceive here in the overall sweep of Passive House delivery, project delivery, is this sort of mismatch between effort and usefulness of the model. And this has real consequences for what we would call the model value. Now, this is a sort of ideal scenario. There's another challenge. So that's one challenge, is that sort of mismatch, especially at the late stages. There's another challenge, which is that and this is what I alluded to earlier, what we commonly see is that too many teams are not actually getting all the value out of their project, especially during the early phases. So especially early on, teams are leaving a lot of useful impact sort of on the shop floor, as it were, and they're not claiming it, they're not grabbing it, they're not turning it into real value on their projects. And so I think the question then becomes, over the whole sweep of the project, or maybe differently in different phases, how do we increase the useful output of all of this modeling? So we have to do this modeling for certification. How do we increase the useful output, the impact on our buildings? And then how do we reduce the effort that's required? So those two things together will help improve the overall value that we get from our modeling process there. Now, the first way that I think we can increase the usefulness, so we'll talk about reducing effort in a minute, but let's just talk about increasing usefulness first. So I think we can increase usefulness by just spending more of our time and focusing more of our energy on the early phase. So just judging by that funny little graph that we showed before, I think model usefulness and utility really peaks at the late SD, late SD, early DD phase. And so moving more of our work into that part of the timeline will yield more useful results or more useful impact on our building. The difficulty, though, is that it's really, really hard to model useful performance models during this phase of a project. It's not hard because it requires a lot of hours. It actually doesn't require a lot of time, but it requires a tremendous amount of experience and a lot of judgment. And that's because during this phase of a project, you have no idea what the project actually is. None of the systems are defined, none of the walls or assemblies are defined, none of the products are defined or specified. So you need to make good, sensible, conservative judgments and move forward and return or yield useful information back to the design team, even in the absence of all of that information. And that's very hard. That's a very difficult proposition, not because it requires a lot of hours, but because it requires a lot of judgment. And so it requires much more experienced practitioners. But I think if we can move more of our work into this phase, we can radically increase the value of our modeling work. Now, during this phase, one of the things that we can do in order to increase the overall value is that, especially during this early design phase, you should never, ever, ever be modeling just one version of your building. You should always be modeling a range of outcomes. You should be modeling, well, here's the building if we were to build it to code minimum standards of insulation, airtightness, mechanical systems. Here's the building if we added a little bit of insulation and we electrified all the systems. Here's the building if we improved the airtightness and added an ERV. Here's the building if we added passive house windows. Here's the building meeting a full EnerFit or PFAS Revive threshold target. Right. So you're going to model a whole range of outcomes, and that range of outcomes is going to give you a sensitivity around which of the elements here is really impacting that particular building. It's going to be different for small buildings versus big buildings, hot climates versus cold climates. It's going to be different depending on the particulars of your building, but you should always be looking at a range of outcomes there, never one option at a time. So it's always looking about options. This is just an example of how we do that in some of our projects that we do professional consulting for. This is a little row house building in New York City. And as a matter of course, during the late SD, early DD phase, we'll output at least 5 different versions of the building and say, oh, here's, in this case, tons of CO2 per year or CO2 equivalent emissions per year based on the different sectors, heating, cooling, domestic hot water. And you can see we're moving through 5 different versions of the building, in this case, code minimum on the left, and then a passive house EnerFit all the way on the right. And using this as a way to have a conversation with the design team about where the real levers are that are impacting the overall building performance and where we can really leverage those on this particular case to get the best, most cost-effective building. One of the other things that I think we need to do a much better job of as an industry, and certainly as a firm, I know we work hard on this, is around communication. So how do we communicate all of this information to the rest of the design team? How do we keep the entire team in the loop, as it were, as we're building out these complex building performance models? What you're looking at here is a prototype application that we created to visualize passive house models in the web browser. So this is a shareable link that we can provide to the entire design team that allows it allows the user in their web browser to go in and interact with, query, and look at the various elements of the Passive House building, from windows and walls to rooms to, in this case here, plumbing, piping. This is particularly useful if you're trying to get coordination across the entire design team about what it is that you're modeling. What is the status of the model? What is built in? What is not built in? What are the assumptions? And making sure that you're making that transparent to the entire design team to make sure that you're communicating that information rapidly or in essentially near real time to the entire design team there. And so working on those communication methods is very, very important. On that front, I think one of the important things that we need to work on is just how we say things, how we write things. You should never, ever, 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 ever use jargon. You should never, ever, 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 ever say KBTU per square foot per year to somebody. You know the square footage of your client's building. Do the math and just say KBTU. Right. You can make everything much, much easier for the people who are digesting it. Avoid jargon wherever possible. Just say things straightforwardly. In the case here, the bulkhead appears to be unshaded and exposed to high summer radiation. Radiation, that's maybe a little jargony. Maybe you could say that a little better. But use straightforward, actionable statements to try and communicate to the design team things that you think they should do in order to improve the performance of the building. So work hard on your communication, both on the visual side, on the conceptual side, and on the writing side. It's very important. Now, on the other side, when we talk about usefulness, maybe that begs the question: who are we? Who are these? Who is defining useful? Who are these Passive House models useful to? And I've sort of taken as a default that we're talking about the design and construction team. Right? The Passive House models have a direct use for the design and construction team. They help you make decisions. Should we build this or should we build that? Should I buy this or should I buy that? Right? That's a very direct use of the Passive House models. So when we talk about usefulness over effort, that's primarily who I'm thinking of when I'm sort of coming up with that equation there. But of course, Passive House models have indirect, or Passive House certification has an indirect benefit to other stakeholders that are part of the project team, right? Especially the owners and in particular the residents. The Passive House models can and do have an indirect benefit on those stakeholders. And then there's a whole other group of, we don't want to call them stakeholders necessarily. They're not really part of the project team, but other entities that may benefit from the Passive House certification or Passive House modeling. Those might be, government or policymakers who might benefit from having, rich data sets or accurate energy models, academics and researchers who likewise benefit from accurate energy models, maintenance and operations teams who benefit from having digital information models of their buildings, quantity takeoff estimators, and then other simulators. If you're working on big projects that are required to do LEED certification, can you double up the usefulness of your building model to do your daylighting assessment, mechanical assessment for peak loads? Are there other ways that you can increase the use of these models that you are creating? And if we are able to do that, or if we could figure out some additional uses for those models, especially towards the tail end, then we could potentially bend the usefulness curve to gain more use, especially in the later stages. And if we go back to my sort of proposition that as modelers, as design teams, we should be paid for the value we create, not the hours that we work, then increasing the value towards the last half of the phase here could have real implications when it comes to overall project profitability. Right? That is all sort of things to think about. Let's just say, we'll call it that way. Those are not things we've successfully been able to monetize yet, but they hold potential. They are potential revenue streams for the future. So let's just call it that. Taking a slight, going back to that though. One of the potential places that your models might be really valuable are to other team members. there's a bunch of reasons why that doesn't work very well right now, but preview of coming attractions. Next week, we're going to talk a little bit about improving your passive house modeling from a more technical perspective. And if we can change and upgrade and overhaul our passive house modeling tools, we can we can definitely move to a scenario where the passive house model data is able to flow in and out of other calculators, which again could mean opening up new revenue sources for modeling teams or design teams, or decreasing costs at the very least. If you're able to move your single model through a quantity takeoff assessment, a carbon embodied carbon calculation, a hourly calculation, and an annual or certification calculation, if you're able to view it in a web browser and on your desktop application, and view the same data in a dashboard that gets presented to the developer, being able to use the model in multiple ways, depending on who it is that you're talking to or where you want to use or what you're working on, is one way to also increase the value of our models. Now, on the flip side of the coin, to increasing usefulness, so one of the things we can do is increase the usefulness of our models, for sure. On the flip side of the coin, we should be working hard to reduce the effort we put into them. To say it again, I do not believe that we should be paid for the number of hours that we work. We should be paid for the value that we create. So stop working so many hours. Stop working so hard. Use better software. Use better tools to execute and output the same high quality model at a fraction of the time. So if you're working on a multifamily passive house building, you should not ever be entering model data by hand. You should be using a better tool. You should be using one of the building information modeling interfaces. You should be using some sort of 3D modeling application. You should be using, pH LiveSync or PassiveLink or Honeybee pH are preferred, or maybe BIM to pH or Design pH. Somehow you should be using some sort of automated, highly automated and more efficient tool to harvest that data and get that data into your passive house models. And that can pay enormous dividends when it comes to assessing the time component for your projects. On that front, one of the other things that you can do is to standardize. So standardize your inputs. Don't reinvent the wheel every time you come onto one of these projects. So in our office, we have landed on a standardization of inputs strategy where we use a cloud-based database to manage all the project data, and then we are able to connect that to our passive house models. Right, so we've built out a whole bunch of software to allow us to do that, but that means that the inputs are relatively standardized. We can move through the data organization and input verification and cleaning phase very, very quickly. Brief aside, when I say standardize, I don't mean try and make catalogs. Don't try and make catalogs. You'll never be able to capture all of the variety of the things out there. Certainly build up your sort of internal catalogs of the 10 window types that you commonly use. But what I really mean by standardize inputs is standardize the structure and the behavior of the data so that your model can anticipate how the data comes in, not what the data is, but how the data is organized and how it works. So when we talk about standardization, I don't mean you're only allowed to use 5 different windows. What I mean is windows should always be structured the same. They should behave the same. They should have the same attributes and fields. And then your model should be able to read that in an automated way. Now, at the same time that we're automating or standardizing the inputs to our models, we're going to automate or standardize the outputs. What you're looking at here is just a view of a project web page that we create for a client. So if a client comes to us and they say, oh, we want to get passive house certification during the late SD, early DD, we would do an assessment model like this. And then we would, deliver back to them an interactive web page like this that has all of the product recommendations and sort of assessments of their particular building. The important piece here, though, is to understand that this this web page is very, very automated. So this, the graphics and the structure and the graphing, those are all automated. So we're able to, through software tools, connect our passive house models directly to these web pages, and more or less, the data is able to flow through from one to the other. And so we're able to move through those outputs very, very quickly. from a high level, like all of this is sort of a long way of saying that we need to automate and invest in tools. We need to invest in our tooling. Again, the problem here that we're sort of dancing around is not related specifically to Passive House. Passive House suffers from it, and we need to address it as an industry. But the overall process or the overall problem within the AEC industry is that we have not invested enough in automation and software solutions. We know that globally, the construction sector, the AEC sector, lags far behind other industries when it comes to overall productivity. And a lot of that comes back to the lack of investment in automation, the lack of investment in tooling. Versus other industries. So we have a lot of ground to make up as a sector, as an industry, when it comes to improving productivity and improving our processes. And of course, the Passive House world is no exception. We suffer from the sort of same issues, I think. Okay, let's finish up here with just a few really, I'll try and save some time. I'm keeping an eye on time. So let's talk about a few early phase modeling tips here, just some sort of really straightforward sort of recommendations. And then of course, we'll save some time for chatting, and I'd love to hear any questions anybody has. But as I indicated earlier, I think one of the main ways that we can increase usefulness is by shifting a lot of our work to the early phase of a project. But it's really hard to model a Passive House project during late SD, early DD, when so much of the building is still undefined. How can you yield any useful results back to the team? How can you say anything with any level of comfort or definitiveness about the project when it's all still so blurry and so mushy? Well, there's a couple things I think you can do. So first of all, keep your focus on the right things. So model SD things during SD, DD things during DD, and CD things during CD. Do not get lost in the weeds trying to calculate every last thermal bridge during the SD phase, when you know that so many things are still going to change. That said, we do want to capture a lot of those unknowns. Anytime we have unknowns in a process or a project, that means we have some risk, and we deal with risk by building in excess capacity. There's nothing revolutionary there. There's nothing really unique about Passive House there. We're going to build in excess capacity and safety factors anytime we have unknowns and we have risk, and that's how we're going to manage that risk. And as we talked about a little bit before, we're not going to model a single answer. We're going to model a range of outcomes, and you're going to focus not so much on the absolute value of the result, but on the trend. If I do this, is it better or is it worse than it was before? That's the kind of thing that we're going to look at during these early phases. But from a practical perspective, how can we deal with risk by adding in these this excess capacity into our models? There's sort of 7 different things that I think you can do to your energy models to build in extra contingency. And I would love to hear if anybody has some others that they commonly use, some sort of tricks that they use in order to manage this early phase modeling risk. One of the first things that I would recommend is to build in an allocation for thermal bridge heat loss. So this is during early SD, late DD. You have no idea what the building systems are. You have no idea what the details look like yet. Fine. Don't get lost spending a ton of hours trying to model a bunch of thermal bridges that don't matter, that are going to change later on. Instead, just use an allocation. Say, oh, okay, during SD, there's going to be an extra 10% heat loss due to thermal bridges in our building. Now, that's going to be very pessimistic. Hopefully, you're going to get that down to 2%, 5%, or maybe 0%. And if so, good for you. But if not, you've built in a lot of excess capacity here. You've built in an allocation for the thermal bridges that you then spend down later during the design phase. Another thing you can do is you can add a safety factor to your U values. So your U values, you can very, very easily just add a quick safety factor. Again, maybe it's a 5% increase in U value, or maybe it's a 10% increase in U value. One way or another, you want to boost the U values of your project assemblies a little bit in order to, again, build in some of this excess capacity. When it comes to windows, one of the easiest things you can do during the early phase, long before you have any clue of what the window products are that are going to be used on a building, is use one of the various window thermal comfort calculators that are available, whether you're talking about PHI US or PHI. Both of them have maximum U values allowable for certified projects. And so in the early phases, if you don't know anything else about your project windows, go ahead and use that maximum U value window, right? That's the maximum allowable window that meets the thermal comfort targets. So just use that one during SD. Unless somebody can come along and say, no, we're going to use this other product, we're going to use this other element. Just use that window or use that value. That'll be a good conservative solution. You'll only ever do better than that. You could never do worse than that, because then you wouldn't be able to certify the project. When it comes to Windows as well, on the SHGC side, always use low SHGC. I mean that for real. Don't go down the dangerous slippery slope of including high solar heat gain glazing. It may make your model look good, but it's a bad idea in almost every climate that we've ever worked in. It's a bad idea for almost every building we've ever worked on. And so my recommendation is strongly to do not get tempted by that easy fix of using high gain glass. It's going to have bad outcomes for your building. So use low gain glass if you're working in North America. Use the highest allowable air tightness in your model. You could input any value you want. You could say during design phase that my construction team is amazing. They're going to get to 0.001 ACH, and you could enter that in the model. You've now sort of yoked your construction team to a really unrealistic expectation. So one of the things we always do, always and forever, is use the maximum allowable air tightness in the model until the building is actually tested. And so you can only ever do better than that number. In this case, it might be an EnerFit project at 1 ACH. Maybe it's a new construction at 0.6. Maybe it's a FIAS project at one of the various air tightness targets there. But you can use the maximum allowable air tightness value for your infiltration. And then lastly, for the ERV, use the worst allowable performance, which in PHI world would be 75% in a cool climate like New York City. It'll be a slightly climate dependent there, but use the worst allowable performance that meets your comfort targets. Use comfort as the sort of backstop on your overall building there. So you can absolutely build these things in from the very beginning. And that means you could get started, long before you know anything about the particular specifications of the project. And then just the very last bit here is and this was required for FIAS, obviously, but is good practice for PHI as well. Do not include window ventilation air change. Just leave it set at 0. That also is going to sort of give you a false sense of security when it comes to your overall cooling energy consumption. So leave that set to a very conservative estimate during the modeling phase. And if you build in all of those contingencies into your model during the early phase, you should have a lot of confidence that you can yield useful results back to your design team that help them shape the project without worrying that, later on, what if so-and-so happens and then I'm sort of way off or spending way too much time trying to model details that don't matter during that early phase. So we can build in a lot of those contingencies there. Okay. Well, the last couple things, and this was already noted before. So, the Reimagine Buildings Collective is going to become a really important resource for all of us. So, I would strongly recommend that you check out the Reimagine Buildings Collective. To that end, this fall we are going to be premiering a members only, so only for members of the Reimagine Buildings Collective, 2 completely new video series dedicated to these issues of passive house energy modeling. So we're going to have an entire video series around PHPP version 10 in IP units. That's currently stands at 65 videos long, and I still have a few more to go recording that. And then we're also going to have a nice complete woofy passive tutorial series as well. Again, video tutorial series. These will be available for members of the Reimagine Buildings Collective. So if you're interested in any of these issues around energy modeling, check out the Reimagine Buildings Collective. And I should just note that these 2 inaugural video series are only the tip of the iceberg. We have an enormous program for the future, including all sorts of advanced modeling topics with building information tools like Honeybee PH, Enerfit PHPP modeling, the new FIAS Revive, WFI modeling, multifamily modeling, non-residential modeling, scripting and advanced data management, all sorts of, I think, interesting topics around building energy modeling. We're going to have a complete curriculum for Reimagine Buildings Collective members only. So if you're interested in any of that, I would strongly recommend you check out the reimaginebuildings.com and become a member, and I'll look forward to hopefully seeing you there. Okay, with that, I'll come to a close, and I'd be happy to take any questions or hear any thoughts that anybody has on anything that we talked about today.
Amazing presentation, and thank you so much. We're going to hand it right over to Kim for events and sponsors.
Thank you so much, Shannon. I know we have a lot of questions to get to, so I'll try to be quick. First up, we want to thank our founding sponsors, 475 High Performance Building Supply, Ingley Architecture, Partel, Rockwell North America, and Zola. Next up, our champion sponsors, Bowiso, Icon Windows and Doors, Intelligent Membranes, PH Air Seal, Source 2050. Our patron sponsors, Brennan, Holzraum Systems, Innotech Windows and Doors, Lamelux, Longboard, RDH Building Science, and Sanderson Design. And our stakeholder partner is NYSERDA. Next up, we have a Accelerator Partner of the Week, and this week we'd like to thank Paul A. Castrucci Architects, a passive house design firm. I'm going to quickly put some links in the chat for everyone and jump right into events. Starting off with our podcast episode this week, we have How Rapid Housing Can Be Better Housing. This is part of a series, I believe co-hosted by Mary James and Ilka Cassidy, all about rapid housing. Next up, as was mentioned earlier, next week we have Improving Our Passive House Modeling Tools with Ed May, who will be joining us again. There's a link in the chat to join us for that one. Same time, same place. The FIAS Pro Forum is coming up October 21st. This will be in Rhode Island, and this will be a workshop-based series, so hope to see you there. We have Building Energy New York City coming up October 24th in New York. And as was mentioned earlier, we have Reimagine Buildings. This is our conference coming up. I have the wrong slide here. It should be How to Decarb. So apologies for that, but the website that I'm sharing will give you the correct information. And our speakers will include Lisa White, Chris Magwood, Lois Arena, Carmel Pratt, Tessa Bradley, Nikita Reed, just to name a few. And this will be a 4-hour conference. We will be joining on a Friday afternoon, October 18th, and AIA continuing education credits will be available for this event. I think that is it for me, and I'm going to hand it right back over to Sean.
All right, excellent, Ed. Thank you so much. What a great presentation. So, because we're close to the top of the hour, if you do need to leave, which I don't know why you would, because this is Ed May time, and anytime you get free Ed May time, you should take it. But if I understand, if you got to go back to work, if your lunch is over, or if you're in BC and West Coast, you're need to get another cup of coffee. If you need to leave, again, come back next week, where again Ed May will be back for the 5th time. He'll be putting on his fancy coat as the most presenter on the PHA Lives. Ed May, amazing. We're all clapping for you for great stuff. Now, if you want to stick around, we are going to do the final 15 minutes where we can get through all the questions that mainly Shannon and Ilka have, but I'm sure there'll be a few more as people catch their breath and absorb all of the wisdom that they've just got from Mr. Ed May. And if you didn't get the wisdom, you just enjoyed the soft, beautiful voice of Ed May as he came with us with this great knowledge of passive house. So that being said, Shannon, I know you had a couple questions. You can kick off the question period with Ed May on construction tech.
Fantastic. Thank you, Sean. Well, it takes one to know one, the dulcimer tones of both of you. I just let those waft over me while the information comes in, and it makes it sweeter. It's like a spoonful of sugar, helps that medicine go down. So, Ed, I'm going to skip some of my questions and jump right into the one that I'm the most interested in for the schematic design phase, which is how often when you're working with a team, does your model or your expertise and that high impact you have in schematic design initiate changes in the geometry?
Oh, that's a really interesting question. The primary area that the early phase assessment yields changes to the architecture of the building is mostly around shading. And I would say it's fairly common that we identify some area in the building during the early phase which is at high risk of poor thermal comfort for either wintertime, but mostly summertime, mostly overheating risk. And so it's very common for us to be able to identify those areas early and then be able to say, hey, we need to come up with a shading solution for this. So I would say that's probably the most typical modification. It is also common for us to recommend things like reduce your north side glazing by 10% or something like that. Like some kind of modest modifications. We operate as kind of a weird entity, right? We're outside consultants. We are not designers. We're not architects. I mean, I am an architect, but we don't operate as architects. And so mostly the way that we approach buildings is that we look for ways to improve performance and achieve the passive house targets while maintaining the architectural integrity or the architectural intent of the design team. Right? We have a lot of respect for and care around the architectural design of buildings. And so we try and maintain that wherever possible. So it's very unlikely that we would recommend something really radical in terms of like, no, do something completely different with your building. But a lot of modifications around shading or proposals around shading, and then sometimes some around being more strategic or more careful with windows. There's no reason to fully glaze the hallway where no human being is going to spend more than 8 minutes. Why don't you, prioritize the glazing in places that, going to make the most impact for people's lives? Those kind of recommendations are probably the most common.
Perfect. Thank you. Thank you, Ed. Great answer. Ilka, you want to jump in and ask one of your questions?
Sure. So thanks, Ed. This was, as usual, an amazing, very, very clear presentation. I just love how you just kind of describe something that can be pretty daunting, right? If you jump into an energy model the first time, or even, after years, it's still a little bit daunting. And the way you phrase it as just putting numbers on things, I think makes it all a little bit easier to attack or to digest. But so I have a question, but I would like to follow up on something that you just said about the shading. So you said, sometimes you see in your energy modeling and you recommend shading, but I do also know that sometimes it's a little hard to detect that in energy modeling models, whether that's WFI or PHPP, because the way you model it is basically a box, and you assume that the temperature is the same everywhere within this box. So you don't actually see if there's a corner or a room of it within the building that actually overheats. So as a beginner, you might look at your energy modeling results and see, oh, I don't have any issues with overheating. But if you have a little bit of experience like you have, you can, you know that there's going to be a problem. But how do you see that as a beginner? How do you recommend, for something that is not as experienced as you to, go around that?
Mm-hmm, mm-hmm. It's a really good question. I mean, a lot of the work that we've done on the software side in particular is around bridging different applications. I think that the PHPP and WFI Passive are great tools. They're really good for certification, but they have very significant and real limitations. They are not good tools for assessing overall thermal comfort. They just aren't. The single zone static model is not a good method of approaching a 6-story row house or a 20-story building from a thermal comfort, especially a summertime overheating perspective. Doing multi-zone models, doing individual room models, doing dynamic simulations are going to be the only way to realistically capture, if you want to really capture those types of impacts. that takes a lot of extra work and a lot of extra sort of a lot of extra hours. And so you're right, a lot of it comes down to experience and judgment. So a lot of times when it comes to thermal comfort impacts, it's not going to be based necessarily on the modeling. We might look at the solar radiation and we might look at the overall massing. And you might say, oh, it's a bulkhead. It's at the top of a 6-story building and it's fully glazed on the south side. Sure, we could model that. We absolutely could model that. But I also know that if it's unshaded in a climate like New York City is going to be an overheated space. We just know that from experience. And so it's a combination of experience plus modeling that allows you to sort of yield the kind of useful feedback, especially early on. You don't want to spend a ton of time doing really, really detailed, hourly dynamic models. And so you're going to rely more on those kind of heuristics to make those sorts of recommendations. All that said, we have worked hard to make the software a lot easier and faster to use. And we've integrated the Passive House modeling with other dynamic simulation tools. And so there's some very good, very fast radiation assessment tools that we can use that are sort of baked into the software at this point that we utilize that allow us to get a very, very fine-grained picture of solar radiation when it comes to windows in particular. And that really helps us a lot identify those potential problem areas. And then coupling together the analysis with those automatic outputs allows you to visualize things. So that's the other side of the coin is, just looking at a list of numbers is, I don't know, I'm an architect, so that doesn't mean a lot to me. I like to see it. And so using those types of automated visualizations of model results are really important because it allows you to quickly identify those problem areas using just your eyeballs. You don't even need to, look at the numbers per se. But then if you see one of those areas, you can dive in and obviously do a more detailed model if you really need to, if you feel like you have to kind of go the extra mile there. So I don't know if that quite answers your question, but that I would say from a high level, we're very, very conservative about overheating as well. It has a lot of problems with overheating in several of our early projects we worked on 15, 20 years ago. Overheating's always been an issue. We still get calls regularly from other people who have had passive houses built in the United States that suffer from overheating. It is the single biggest issue with passive houses in the United States, and the models can sort of send you down the wrong road, kind of back to that high solar heating crutch that a lot of people lean on. The models can very easily lead you to believe that you're building a building which is okay, and then in reality it has a significant overheating problem. And so I think that is something we have learned to be very cautious about and very nervous about with all of our projects.
I just have a really quick follow-up question to that. So do you think that in our climate, shading should be mandatory for a passive house? Because right now you can get away without it, right? You don't have to. But with the experience that we've been gaining over the last so many years, I mean, you would think maybe it should just be a passive house principle, depending on climate. What do you think about that?
Yeah, I think there are a lot of ways to attack it. I think looking at annual cooling energy performance is not a robust way to deliver comfortable summertime buildings. I think that's not good enough. And so I think there's a lot of ways you could conceivably attack the problem. I have to say, I really like the new FIAS Revive strategy of focusing on summertime resilience, saying during a power outage, how does your building perform for a critical week in the summertime? Those types of assessments are going to yield very, very direct, I think, very direct impacts on building design without a ton of work. Doing a week simulation is a whole different thing than doing like a full year hourly simulation, right? You have just a whole different, magnitude of data that you're sort of wrestling and dealing with. And I think that approach, we've used that approach in the past in wintertime, around wintertime resiliency, power outage, and then seeing how that can help affect the building design very directly. And I think that new FIAS Revive strategy of doing that in the summer is very smart, and I think will yield tremendous benefit to a lot of projects. I think that'll force people to do the right thing in many, many cases, even if maybe the annual simulation says, I think those more targeted assessments are very sensible and the right direction for us to be moving.
hilarious. You know, my model makes that sound for the angle simulation too. And I really like your advice about taking that solar heat gain coefficient number, you know, to its logical conclusion with regard to letting it act as the shading, right? Rather than the gain. So we've got another question here from Douglas Massey. Douglas, would you like to unmute and ask your question? And Douglas, if you are no longer.
Trying.
Oh, you are with us. Hello.
I am. So I noticed you had a slide that had multiple softwares that bring it from SketchUp. I'm guessing they're all extensions that go into SketchUp and that will all flow into PHPP?
Great question. Great question. So that slide was showing several different software options. So there are lots of different softwares available now. Only a few of them work with SketchUp, though. So there is Design PH, of course, which works with SketchUp and is able to connect to PHPP. There is the Woofy Passive SketchUp plugin, which allows you to connect Woofy Passive as well. Then there are two other interesting applications that connect Revit, the Autodesk Revit, to the Passive House tools. So one is called Passive House Live Sync. That's a tool made by a developer down in Australia. It looks like a really promising solution. Looks really interesting. And then there's another one called Passive Link, which is made by a group out of Spain, I believe. They were working with Tomas O'Leary recently, and so I'm not sure the current status, but both of those were Revit-based tools. And then our firm, we created and maintain a free tool named Honeybee PH, which is a Rhino 3D interface. So depending on the tool that you're doing your design phase in, you may choose one or the other. And then there's BIM to PH, which is a generic IFC to PHPP interface tool. So there's a whole kind of range of different tools that are available now, depending on the software that you're working with. And so you might choose to pick up any of those.
And so Honeybee will work as an extension in SketchUp?
So that one, that's a good question. That one is designed for Rhino 3D, which is another 3D modeling application. Okay. You probably could install it in SketchUp, but I'm honestly not sure. I haven't used that myself.
Okay. And in your experience, what's the easiest one?
So what type of project are we talking about? What scale of project are we talking about?
Single family residential.
Single family. So in that case, I would say the Design PH tool is probably the most straightforward. If you're doing SketchUp already, then the Design PH is probably a great solution for single family homes.
Okay. Thank you.
Sure.
Great stuff, Douglas. Mario, you had a question. Over to you.
Hey, good morning. Can you guys hear me? Okay, here we go. Thank you guys so much again. Good to see you guys this week again. I guess my question is, so you find issues, I mean, obviously you'll be able to simulate more, you'll be able to model more as the more projects we can analyze out in the field, how things are correlating. But so what you find now is there sort of a feature with your modeling where you can input your IGUs or all your parameters, kind of like with SolidWorks when you're doing like alloy fabrication, like you're fabricating, you can actually input like the alloy composition. It'll tell you like the tensile strength. Obviously, we're not talking about that with this, but is that sort of what you find, like you were saying earlier, that doesn't really work, or there's not a place for that yet in the software we're using? Like say if we were to, because we have, let's say we have the PHI certified window units. Are those now being input into the softwares? Is there like a performance kind of AI model for understanding if I go with these windows versus if I go with these windows versus if I go with these windows? Obviously, like you said, it's probably better to have a very safe baseline for all your numbers as opposed to specifics. But do you see that integrating into the new softwares, the softwares that are becoming more prominent in the modeling?
Yeah, that's a really good question. On the ingestion side, so you're talking about like how do you get data from a product into the
Yeah,
model, kind of like
yeah.
what does the process
Considering
there look
Passive
like?
House already has a lot of data on these specific materials, and
Yep.
they have long use of Gutex,
Yep.
Rockwool. Those products have been used a lot. Especially
Yeah,
since
there's
myself as a builder, I want to move more towards natural products, the timber insulation, getting away from hard embodied carbon stuff, and
Mhm.
just kind of like you said, if you were to build those several stages of the model, if you decide to go with natural products, these are your options. These are what your numbers look like. If you decide to go with these more affordable, readily available at a Lowe's or at a regular hardware store with Rockwool
Yeah.
and stuff like that, where your cost differences are, and then that way you build a better picture for people for people and their preferences. Because myself, like I said, I want to
Yeah.
try to go into natural products as much as I can. So
Yeah. That makes a lot of sense,
big
right? And you
question.
want to be able to, it's a great question. And you want to be able to move through those types of assessments really rapidly, right? And say
Yeah.
like, oh, here, let me change everything with sort of one button kind of thing. Those tools do not exist yet. So the
Okay.
tool you're describing doesn't exist yet, right? And that's part of what we're arguing here is that what you've described is exactly where we need to be moving towards.
Mhm.
And the problem is that the current tools really don't support those use cases very well. It's
Okay.
still incredibly laborious. It's incredibly prone to
To
error.
code all that.
Yeah, it requires, somebody who really knows what they're doing to input everything in a sort of very laborious fashion. And looking at those types of quick variants is very, very difficult. And so we need to, though, move towards the scenario you're describing, because I think that
Yeah.
is the use case that we need to be able to support as a passive house community. That's how we need to sort of change our modeling processes, move away from the sort of bespoke academic modeling universe towards a rapid real-time assessment, model where we can really deploy it at industry scale. I think that's
because then that way it becomes accelerated. Like say I build cars. This is just a complete side note. I build cars. I don't know specific. I'm starting to learn more about camshafts. So, but if someone knows like what horsepower do you want, where do you want to sit? What do you want my gas mileage? So if you build these kind of models, I know I'm getting away from that, but it's kind of like the same idea.
Yeah.
To where you start to understand, and you don't have to have this bespoke academic, something that's readily available. So when new vendors are coming out, say a new vendor is going to put out a product line, they can either, if they see this passive house thing coming around and they're still not as convinced, and then they start reading all the information, all the data. Now I know that this is a bit far off in the distance.
Actually, Mario, you are totally spot on. We absolutely love this perspective. We talk about this kind of integration all the time. And I also love that you are running around the job site right now. This is very fun to
I
hear
just
your
pulled a
input
kerosene
and
tank.
to see your background.
I just pulled a kerosene tank off of a Santa Fe caboose. So
fantastic.
Yeah.
Thank you for your questions and for joining us. We have to wrap the show, but we would love to see you again. And please come back for Ed May's follow-up presentation next week. We will continue this conversation. And Ilka, why don't you thank Ed and take us out? Ed, fantastic.
Yeah, thank you, Ed. This was an awesome first live event for me as a host. So that was great. And yeah, I hope to see you all next week and next month again. And we have so many more things to share. So thank you, everyone. And thanks, Ed, again.
Thanks, everyone.
Thank you for the invitation. It was awesome to be here with you. And thanks everybody for attending. Great to see everyone.